This presentation is the second of 3 presentations on calculating and interpreting a z-test. In this presentation, we will learn how to use the formula for the z-test properly. And in the final presentation, we will learn how to interpret the results of the z-test. Let's take a sample question and create hypotheses for it, as well as calculate the z-test result. As we recall, the z-test formula is as follows. The z-test is equal to x bar minus mu divided by theta, where x bar equals the mean value of sample variable x, mu equals the population mean from which sample variable x was drawn, and theta equals the population standard deviation value from which sample variable x was drawn. Remember that in order to use the z-test, we need to know what the population mean and standard deviation statistics are. We have to be given these statistics and trust that they are true. It's equivalent to having an omniscient narrator who knows what happens to all the characters in a story or novel. Thus, the first hypotheses we will consider for inferential statistical testing are based on how different our sample mean is from an overall population mean. Here's our problem. The mean absentee rate for the population of students in the local school district is reported as 8.45 days per year with a standard deviation of 2.56 days. The mean rate for a sample of 25 students enrolled in a vocational training program in the school district is reported as 6.79 days per year. We need to first answer the following question. What is the null hypothesis? The null hypothesis, in the vernacular, means that nothing happened. Or more formally, there is no statistically significant difference between the sample mean value and the population mean value. Transferring this principle to our problem, the null hypothesis is there is no statistically significant difference between the mean absentee rate for the vocational training students, sample mean, and the mean absentee rate for all the students in the local school district, the population mean. If there is a null hypothesis, then there must be an alternative hypothesis. In our problem, the alternative hypothesis is that there is a statistically significant difference between the mean absentee rate for the vocational training students, the sample mean, and the mean absentee rate for all the students in the local school district, the population mean. What is the result of the z-test? The result is as follows. 6.79, the sample mean, minus the population mean of 8.45 divided by 2.56 gives us minus 1.66 divided by 2.56, which equals minus 0.65. The absolute value of minus 0.65 is 0.65. In the next presentation, we will discuss how to interpret the results of the z-test.